Now talking about the thumb rule for the calculation of current. Okay, thumb rule for the calculation of current. I never recommend to go with thumb rule in real time way. Thumb rule is actually used to get or to crack the results in a fraction of a second. That's it. Or to crack your interview also, I can say, because if in the interview, if they ask you that for 5 kilowatt or for 10 kilowatt, how much amount of current needed? So you cannot go with the complete formula P equal to root 3 VI cos phi and substitution. That is a time taking task. So simply you can go with this thumb rules. So here when you're working with secondary side means what? Nothing but the low tension side of transformer you can say, or star side of the transformer you can say, or output side of transformer. Everything means the same. Different people will call it as different way, but everything means the same. So conversion of kilowatt to ampere. So whenever you're going to work for three phase, the multiplying factor is nothing but 1.74. I'm talking about active power. When you're working with single phase, the multiplying factor is 5.43. I'll explain you these things with examples. Again for kVA, when you're going to work for three phase, the multiplying factor is 1.39. When you're going to work for the single phase, the multiplying factor is 4.32. For kVAR, as we have only one system, three phase system, okay, so it is 2.32 for us. Now, if you're working, generally we won't work for the primary side, but if you're working or if you are being asked to check the amount of current at high tension side or delta side or input side of transformer, everything means the same. If you're having a POS of 11 kV, what is POS? Point of supply, source of supply from transformer. In the last class we have discussed, in 90% of cases 11 kV will be the point of supply. I have told you. So if you're having a point of supply of 11 kV, in that case the multiplying factor will be 0.052. If you are having a point of supply of 33 kV, in that case we have a multiplying factor of 0.0174. So now, okay, we are going to substitute, okay, a few examples so as to understand these thumb rules in a very clear way. Like I have a 3000 kilowatts of load. Okay, I'm working with the low tension side of transformer. So for 3000 kilowatts of load, go with the formula P equal to root 3 by cos phi, which is very lengthy process. So simply what I'm doing, I'm multiplying with 1.74, I'm getting the current value. So here I'm going to overcome all the formula procedure. You can cross verify by using the formula also, you will be getting the same answer. Again, you can see for 0.5 kilowatt, okay, or 500 watts you can say. So as it is less than 5 kilowatts, so we go with single phase. For single phase, we have got 5.43 as multiplying factor, which gives you 2.71 ampere. For conversion of kVA to ampere, for 125 kVA, so 125 into 1.39, if it is a three-phase system, which gives you 173.75. Again, for 10 kVA, as this is single phase system, we are getting 43.2 ampere. For kVAR, we have 5 kVAR, for example. So 5 into 2.32, which gives you 11.6 ampere. All these examples, you can able to substitute with your formula also. 99.99% you will be getting the same answer. You can cross verify. So here you are saving your time. But I don't recommend in the real time way to work in this way, because this is not a professional way. If you are working with the high tension side, like I have told you, if you are having a point of supply of 11 kV, the multiplying factor is 0.052. For example, in my project, I have got 500 kV of transformer. Okay, so what will be the amount of current at high tension side? Multiply with 0.052, you'll be getting 26 ampere. If you're having a point of supply of 33 kV, the multiplying factor is 0.0174. I have got a kV of 630. So the current at high tension side will be 10.962 ampere. The same calculations, even if we apply by using the formula, you will be getting the same answers. Okay, so I want everyone, okay, to please memorize all these multiplying factors. And when you're going to work with your assignments, I want everyone to please work with your thumb rules also. When you substitute with your formula, apply with the same with the thumb rule also. Following everyone? Please go through.
Yes.
If any query, you can please clarify. Everyone.
Actually, 26 ampere of current means 26 ampere of current in a second or minute, something like that.
No. We don't. We never resemble in terms of time.
But we have a unit called ampere hours, kilowatt hours for
See,
battery.
that is when you talk about kWhr for the energy meters, or
Mhm.
for your battery banks, we have the AH capacities. That is a separate case. We are not relating the current parameter right now with your hours or seconds or time. You can see,
Yeah.
Even,
I talk
sir,
about,
even our mobile batteries, they are also in mAh, milliampere hours.
yes, definitely. You can see the basic definition of frequency is what? Number of cycles per second. In 1 second, how
Cycles
many cycles you are
per
having?
second.
Okay, the positive wave and the negative wave. Okay, so which are nothing but 50 or 60. At present, we are not talking about those values, because when you're going to find out that how much amount of electricity bill you are getting, at that point of view, you need all those parameters. Like when you're going to calculate the battery size based upon the load, I need something like, okay, 30 minutes as backup. So what size of battery I need? That I have to see. That I have to check. Falling, like I'm having a load of something like 30 kVA. And for this 30 kVA of load, whenever if there is any kind of interruption from the transformer supply, I need a backup for minimum 30 minutes. So in that case, I have to find out the ampere hour. There the term ampere hour, okay, hour generates. So at that point, I need that parameter. Or if you're working with project, there if they ask you that how much amount of electricity bill you are expecting based upon this current value, at that point we need the HR value. Getting, Mr. Anand?
Yeah. Okay.
Yeah, in one of the topic of UPS, I'll be explaining about this in the ampere hour calculation.
So I have a doubt. Like, suppose if an equipment is 1 ampere or 25 amps, what does it mean?
If the equipment is having a parameter of 25 ampere, what does it mean? That means this device needs this much amount of current, or this device
Usually,
can able to sustain this much amount of current.
Sir, we have multiple devices in our home. Some needs 1 ampere, some needs 25 amperes, some needs 20 amperes, some needs milliamperes. But the source is a constant, 230 volts coming from the
From the supply.
grid station, from our meter, from the
Yes,
supply.
yes.
How these devices, how they are intelligent enough that they take themselves, or any, what is that
They take
factor
themselves with
which
this. They
divides, which gives them, you take 5 ampere, you take 1 ampere. Who distributes
see, no one
this?
distributes.
Well,
Okay.
sir, please, my questions. I'm sorry,
No,
but
no. See here.
to,
See.
to clear
Okay.
my concept,
No, no. You can see here that, okay, in the first chapter we have discussed about electron theory. When you talk about any conductor,
Aiva,
we have electrons. Okay.
exactly.
When you talk about any conductor, we have electrons in that. So we are not telling the electrons to move here or there. Whenever you are going to provide a potential difference, these electrons will start move. So wherever we have the least amount of resistance value, these electrons will move. For example, in your home, you're having some 5 points, for example.
Okay.
So these 5 points are having some different amount of current requirement. 1 point you have connected with 1 square mm of cable, 1 point you have connected with 2.5 square mm, 1 point you have connected with 4 square mm. So based upon the demand of load, these electrons will start move based upon the resistance value. You're not applying any kind of pressure. You're not telling to go at this side, to go at that side. By default,
Yeah,
by nature, they are moving.
exactly.
That is what the
So,
electron theory means.
no, sir, that is okay. But I want to understand how, the supply is a constant 220 volts, but
Yes.
one device is taking 10 ampere from the same supply,
Yes, nothing will
one
happen.
device is taking 1 ampere.
Exactly, exactly,
Sorry?
exactly. See, the voltage is 230. First of all, understand the difference between the voltage and current parameter. What is voltage? The potential difference what we have between the two endpoints. And this current is actually a flow of electrons via your voltage medium.
Got it, sir.
Getting, Mr. Fahad?
Yeah, sir. I am getting this point, but actually, what I want to understand from you is, it's something very small thing, but I hope you can clear my concept. How actually, for example, which is the distribution system that because the voltage is 230 is going in even in 1 ampere device and in the 20 ampere device. It is
Okay,
something
fine.
inside the device which actually and make sure that we will not get more than 1 ampere. It is inside the device. There is a mechanism.
Exactly. See, for example, I'm using a bulb. Okay, so my bulb need almost like 0.2
Exactly.
ampere
Okay.
of current. My bulb needs 0.2 ampere. So the manufacturer will make a bulb in such a way that it will consume only 0.2 ampere of current. The driver circuitry, you can say, or
Got
the
it.
mechanism what they are using, or the technology what they are using. The
Okay, sir. Okay. Yeah.
2 ampere of current, because if it is taking more than 0.2, you'll be having a barrier. It will not allow. Insulation will break.
Now got it. So it means, Jenny, the manufacturer actually
Will make in such
uses
a way
different
that it
equipments
will
which
not.
make sure that this equipment will never get more than the desired current value.
Exactly. Okay, like
Answer to make sure that we will not get the more than the desired value, we use more resistance, or which electrical components are used for this.
exactly. When you want to make a barrier, you can increase the resistance value. Like you can take a simple example of your potentiometer. Means what? Nothing but your dimmer or regulator. I can say fan regulator.
Exactly. Yeah.
We can able to vary the
We can
value.
change the RPM of a fan.
Exactly the same thing. We are making a barrier. The potentiometer is a topic what we have inside that potentiometer. Yeah, Mr. Anand, you were asking something. Suddenly you got disconnected.
Yeah. There was a interruption with the internet. So
Okay.
actually, I was asking something similar regarding amps. Like, for example, on lights, we can see amps written on the light.
Yes.
So, what does it mean? That was my question. Like, how long will it take that particular amps? That was my question. But I think it's clear now.
See, now one more thing you have told me here, that till how much amount of value this will take this much amount of current. Like they have given something like 1 ampere. Always remember that during the initial time, for a fraction of second, the value of current will be high for a fraction of second, because nowadays every light is inductive in nature, not going with any kind of incandescent lamps. Incandescent lamps are totally outdated. The bulbs, okay, which we used to use almost like some 10 to 15 years back. As we are having the LED lights, we are having the CFL and the FL lights. So we have a choke, a ballast, and a driver circuitry. We have some inductivity over here. So initially the amount of current will be high. The manufacturer will not specify the initial current, extra current for the light. Okay, you can take 20% extra of your capacity. Like they have given something like 1 ampere. So take 20% extra of your 1 ampere. Like 1.2 ampere it may take during some amount of time, like for 1 second, for 0.5 second. Then again it takes, okay, the same value of 1 ampere. Following? In the future, we are going to discuss about all those things in chapter 4, inshallah.
Okay, sir.
Yeah.
Thank you.
Yeah, Mrs. Swati.
Sir, I have a one doubt. When we using thumb rules for calculation of current conversion from kilowatt to ampere, we derive this formula and get 1.74 for three phase, right? By using 1000 divided by root 3 into 230 into 0.8 from 0.052 in primary side and HT side. Can you please derive that formula here?
This is the challenge for
So
you itself. I can say,
I think
I
that,
can.
but I
No,
can't solve this.
no. You have to solve. I know. For example, in your country, you are having a voltage of something like 440. In your state or in
Mhm.
your country, for having a voltage of 440, so this multiplying factor is not applicable, because this multiplying factor is applicable only for 415 and 230 volts. But in your country, you're having a voltage of 405, 220, or 440. In that case, what will be the value? Mr. Rizwan getting? Like in Saudi Arabia, we have 13.8 as level as point of supply, 13.2 as point of supply. So what will be the thumb rule? Because for 11 kV, we got 0.052.
Yes.
But for 13.8, 13.2, what will be the value? Getting, Mrs. Swati?
That much from we have
Like
to
if
multiply
you are,
that much.
pardon?
We have to multiply 13.8 divided by 11. Then we'll get it.
No, try.
Yeah, yes.
You need to try. This is a puzzle.
Yes.
Very important thing. This is actually very, very important and very technical point of view. I really appreciate Mrs. Swati. Okay, but you have to try. Please try, please try. Okay. You can all take one more challenge also. Okay.
Sir, can you revise the question of
This
Miss Swati? What she actually
Yes,
asked?
I'm getting for that only.
0.052 we are getting
0.
1 divided by root 3 divided by 11. It's 0.052.
Okay, for 13.8.
13.8 1 divided by
What was the question actually?
Yeah, I'm coming for you, Mr. Fahad.
0.041.
0.041 for 22 kV.
For 22 kV, yeah?
22, 33,
Yes.
33 or 22 kV. And 33 is there with us. Okay.
22, yes.
22.
0.026.
0.026. I'll explain
because 22 is a double of 11. For 11.052.
Okay, fine. I agree. Anyhow, okay, Mr. Fahad. Okay, the question is all the multiplying factors which I have given. Okay, like 1.39, 4.32, 5.43, 1.74. These are applicable with a voltage of 230 volts or 415 volts. But if in your city, if you're having a voltage of 220 or if you're having a voltage of 405, 440, then what will be the multiplying factor? Okay, the question is how I have developed this 1.74 value, how I have developed this 5.43 value. So I'm leaving on you, okay, that please try on yourself so that you can able to develop this formula, this value, sorry. Clear with these two chapters, then inshallah next class will be very, very clear for you. The next class is totally theoretical and very important because here we are going to understand about all the electrical, okay, equipments as well as the components and the codes and standards. The theoretical but very, very